repositories, our Android and our iPhone repository a week. And we were releasing an application that was available in 15 different languages, and it used a lot of native functionality, like GPS libraries, things like that, to get information about where an athlete was in real time so that we could record that. It also integrated with third-party devices. So you might also have an external heart rate monitor or a cadence meter on your bike or something like that. The app was communicating with all those devices as well and recording all that information. There was some real-time functionality. So if I was about to run a particular stretch of road that I was interested in, I could get a notification about that I was about to start it. And there was like real-time push information as well. So I could tell my partner that I was starting a run and where I was, so she could kind of follow along on that process as well. So lots of functionality just in the record part as well. And then there was also, the experience after I had uploaded. I could add pictures, I could comment on friends' rides, I could give them support. There's like a lot of functionality there as well. So when we think about continuous delivery, we're often thinking about websites, and yes, we have a website at Strava. Yes, we use continuous delivery for that. But I wanted to just give you a little bit of background because we didn't accomplish automated continuous delivery for like a simple CRUD application on the mobile side. We actually accomplished it for something that is used outside in the real world that is relatively complex. But there's a few other hiccups with mobile continuous delivery. So how many of you have heard this motto, move fast and break things? It's probably most. I think it was popularized by Facebook. And for websites, it makes a lot of sense because every time you refresh your website, every time you navigate from one page to another, you effectively have an opportunity to get a whole new fresh version of that website immediately. And for mobile applications, that is not the case, right? It takes a while to install something. It takes a while to reload it. Even if you have auto update installed, you often have to go through an approval process with Apple before you can actually start using that application and distributing it to your users. You have a limited number of releases you can do a day. So it's not as easy to just fix something. And we also just have different expectations around mobile applications. I had a friend who was a user of Strava who had a minor bug in the application, and we checked the version of her application, and it was actually 6 months behind the most recent release. And she was still able to use the app. She just had a minor bug. When she upgraded, it fixed. But can you imagine like navigating to a form on a website, filling it out, letting it sit in your browser for 6 months, then going back to it and clicking submit? How many of you think that would actually succeed? But it's just impossible, right? We know that's impossible, but that's our expectation with mobile applications. They will keep working forever, or almost forever. We also don't rate websites. Well, we sort of do, but it's not critical to their success, right? We have app stores. Apps get rated on app stores. A bad rating can really hurt your business prospects, not just that particular version of the application. And there's another component for Strava, at least. This is me. This is my dog, Barney. He used to go on trail runs with me. He has now gotten older and cannot. But when I go out on a trail run and I have a new version of the application, I want to know it works. I can't update that application while I'm out on the trail because I have no connectivity, right? The stakes are higher because I want that app to work outside in the real world where I'm not connected to Wi-Fi. So we can't just move fast and break things. We need to change the motto. This is the mobile delivery pipeline motto. It's move fast and don't break anything. Because the stakes are just higher, right? It's more difficult to do this for mobile applications. So why do this? Why even move quickly, right? Well, we definitely wanted the sort of classic continuous delivery benefits, which is if we can get our stuff in front of users sooner, we can get feedback sooner, we can deliver value and update that application sooner and deliver value to our users sooner, right? We definitely want that. We were also getting pretty into A/B testing in 2017, and we now run orders of magnitude more A/B tests than we did then. But A/B testing kind of depends on quick delivery, right? If you have a 2-week release cycle and you miss that cut by just a day, you have to wait 4 weeks before you can even start getting your application out in front of users and start gathering feedback. That is just too long. You can't actually make lots of data-driven decisions if you have a slow pipeline. And there's also stability in moving quickly, right? Moving quickly means you're cutting more often, you're releasing smaller change sets, so there's less to test, right? There's less of a surface area where something can go wrong. And because you're moving quickly, you probably have a computer doing everything, and a computer doing everything makes fewer mistakes. And because it's happening frequently, if there are mistakes, you find out about them quickly as well. So we wanted all three of these things. So what did we actually do at Strava? How did this work for us? So at the very beginning of Strava, a mobile developer would make a change. She'd look over to a coworker and say, hey, is this a cool feature? Her coworker would say yes, and then she'd release that application. Obviously, that was not going to scale. So as we added more engineers, we kind of needed to adopt some release management practices. And at Strava, releasing a train is called, releasing a mobile application is called train conducting. And the engineer who is responsible for getting that train to production, getting that train to the station, is the train conductor. So we had about 25 mobile engineers at the time, and they almost all of them contributed to that release train conducting operation in shifts. So the knowledge was sort of spread amongst all of them. It was all driven through this large playbook, which was a single README file. It had all the commands you needed to run, all the communications you needed to hit, all the Slack messages you needed to send, all the people you needed to communicate with. It was pages and pages long, but it had everything in there, so you were safe if you followed the doc. The problem was it was huge. Especially, it was just extremely tedious because you did have to communicate with QA testers, you did have to communicate with translators, you had to communicate with product managers and other developers. And this was not modern train conducting. This was old-timey train conducting where you had to shovel the coal into the engine of the train to actually get it to the station. For example, actually, when we released binaries for beta testers, you would actually have to build it on your own machine, upload that to the Play Store or the iOS store, incorporate testing translations or testing instructions for the testers by copy pasting them from a Google Doc. You'd have to click through a lot of flows, and then that would finally go out. It was extremely manual process, right? And we ran a survey at the beginning of 2017, and we found out that we were spending about 20 hours a week in developer hours a week, actually just managing this process. And unsurprisingly, it was very complex, right? Our survey demonstrated that it was easy to forget steps, and it actually caused the train conductor stress to have to do this process. And obviously, the worst part was that if we ever wanted to reduce the amount of time we'd spent train conducting, we'd have to do all that work in half the amount of time. Or we'd have to just add more hours to the day, I guess. So let's talk general strategy. How did we actually go about this? We basically took this strategy. We were gonna convert our README into a bot. And then the bot was gonna do everything. People wouldn't have to do it all. But actually, I'm just kind of put this slide in there, but it's actually important, having a playbook of what is actually happening as a first point before you actually begin automating your process is really important, because you are going to document all of your ad hoc processes. You're going to document all of your random assumptions that you have, and you will be able to actually challenge them and determine if they are necessary or not. And it'll act as a beginning part for your conversations for all the train conductors to figure out what you actually need to automate. So the next step is to just kind of pick your bot. And the three important criteria here are that you have something that can respond to changes in your version control, right? If someone commits something, you can do something. The next important thing is that you can schedule events based on the time of day. And the final thing is that you can schedule events based on other events that happen. So if the binary gets built, then you can release it to production next, right? That kind of interaction. So at Strava, we have a CI system. It's built in-house. It's called Butler. It's distributed. It runs in Amazon Web Services. And this is the bot that we chose to amend so that it could do our continuous delivery pipeline for mobile. Butler is configured with a Butler YML file. It lists out all the steps for build, how they're parallelized, what they trigger, how they run. All that information is in version control, so it's easy to kind of keep track of. And this is where we were going to put our entire README effectively, but in code. Well, maybe shelling out the script as well. The final thing is we want to do one thing at a time, right? We didn't want to just stop releasing mobile applications for 3 months and fix our pipeline and then start releasing again. We wanted to be able to continue to deliver value. And so the way we figured we would do that is we would take each individual step in the README and sort of translate that over one thing at a time. So we'd begin by scripting a piece of the README and actually having developers run that script first, ensure that there was confidence around that. Then we'd Slack it, which meant we'd add a Slack command around it so the developers could run it through Slack instead of having to run it on their own machines. And finally, when they had enough confidence in that, we'd schedule it, and that would run automatically and they would no longer have to do it. So this is sort of a bird's eye view of the process. You don't need to know all these pieces. The top triggers are the reasons that we actually want to build a release for beta or for production. And then the flow chart is all the steps that need to be followed in each case. So when translations are complete, we import those, we build the beta, we update release notes for the testers, then we release that beta through the App Store, and then we notify people on Slack that everything has gone correct and maybe notify other channels as well. So we were going to replace all these boxes with scripts. And the first thing we started with was the release branch, right? So every 2 weeks, we'd cut a release branch. That would be the place where we'd put all our bug fixes and the thing that would actually get to production at the end. And the way this happened is a developer would come in on Monday and they'd say to their coworkers, hey, I think I'm going to cut the branch around like 11 o'clock. So if you want to get anything into the train branch before then, just let me know so that like I know it's in there and then I can cut the branch. And then they'd have like a negotiation about what could actually get into the train branch. And then someone would chime in at 12 and be like, hey, have you cut the train branch yet? Can I get something in? And there was this like, massive amount of communication around this thing. So we actually moved to scheduling this thing almost immediately. I think it set a much better tone for continuous delivery. And this is sort of a screenshot from our schedule UI. It shows that we are actually going to cut the train branch for both of the Android and iOS repositories at 1 o'clock in the morning, so no one has an opportunity to have any say in that. But the biggest benefit of this was that our notifications became automatic, right? The next train was calculated using a computer, the next train cut was calculated using a computer, and people were no longer making mistakes. There were so many times where people would like cut train 38 when they actually meant to cut train 83, and then they'd have to like undo their work and redo it because humans just were like attracted to making these kinds of mistakes. Computers just are not. So the next part of the process was actually building binaries, and we really wanted to get this right. So we started with building an alpha every single night in a continuous delivery, in a continuous integration service, and then distributing that to employees. So because our employees a lot of them are avid Strava users themselves, they were able to actually validate that the build was building every single night correctly without impacting outside real users. And we were able to kind of gain confidence around the fact that a computer somewhere else, not our own developer machines, was actually building that build. We began scheduling that, so it ran obviously every single night, and developers could come in the morning and download a new version of that application and start playing with it to make sure that it was working. The beta was a little bit higher stakes, but at this point, because we'd been running this alpha every single night, we kind of had confidence that it was going to build on an external machine. So the thing we really tackled in this step is that we added a Slack command for it. So this is sort of our / butler command. It runs in Slack. It says, hey, butler, I want you to run this particular build. And the build is on the Android repository. So this could be like Android or iPhone. It would be the beta build, not the production or the alpha build. And then this is sort of the Git reference that I want you to run this on. In this case, it's the train 36 branch. It's the 36th train. And if you ever forgot this, you could just kind of use a butler help command, and that would kind of help you along the process as well. So it was really, really easy for developers to do this. Once they were doing this, and they had confidence around this process, we started, one more thing. With that process, binaries were getting built elsewhere, and they were getting archived already, so developers could just download those, test them, and distribute them to QA testers. Once they were confident with this process, we started scheduling the build and trying to figure out how to do that. So with QA testers, we needed to be a little bit more careful, right? We didn't want to just distribute a new binary to them like multiple times a day because they wouldn't have time to test the one we had just sent them. We might be getting feedback for a binary that's out of date. So we kind of played around with this for a little while and figured that we should probably build a new beta binary about once a day, or maximum once a day, if there'd actually been any code changes. And that was sort of a reasonable amount of churn for our QA testers. So that worked. Everything was getting built, but not published automatically yet. The next thing we wanted to tackle was translations. So translations were extremely manual. You had to get the source strings from the source repository, put them into an email, yes, an email, send them off to the translators and say, hey, please translate these. You'd wait about a week, and translators would say, hey, here are the translated strings. You'd download that file, you'd incorporate it into your repository, and then ship that. So we started by tackling sort of the end of the process first. Instead of having developers wait for an email to come back, we would just import translations directly into the source repository every single night. And now the problem with this is that developers were used to knowing that translators had actually translated everything, and they were getting a fully completed version of the application with all the strings available to it. So what we did is the first build here is just an import build, which runs every single night. It pulls in whatever's available, and that runs every single night. The second build is a validation build that runs near the end of the pipeline and actually checks that all the strings are present. If they aren't and it fails, it notifies the train conductor so that the train conductor knows that there's actually action that needs to be taken. So what we really wanted to do here is we wanted to shift from waiting for translations to be ready to only getting notified when there's an issue. Effectively, you can put it out of your mind unless there's an issue. That's sort of the main cultural shift we wanted everyone to get used to. Assume everything is going to be okay. We will let you know if it's not. So that's how we accomplished that with the import task. We then talked to our translators and said, let's just get rid of the emails. We'll send you strings, check every single day if they're available, translate them, and that'll be the end of like the transaction. And this wasn't actually a very big ask for our translation provider because we were already doing it for the website. And again, the final part of this was starting to push translations. We started doing that every night as well. So translations would be available much sooner, as soon as they were sort of committed to the code base and the translators had time to turn those around for us. The final component of this was that we also needed release notes for our mobile applications. And those were generally put together by PMs and developers. And then developers had to kind of coordinate with a bunch of PMs and figure out what needed to be in the release notes, and then like copy those into the repository and get them sent off as well. So we built a nice UI for PMs to do this directly. The submit button would actually submit these strings to our translators, so the developers didn't have to be involved at all. Again, just taking the developer completely out of that process and allowing PMs to just be more effective. So let's talk about actually publishing the beta. So again, we're publishing to Google and we're publishing to Apple. And with these companies being multinational, huge corporations and running huge app stores available in multiple countries, you would think they have some nice REST APIs where you can just upload your binaries and with like a curl request and everything just works smoothly, and you would be wrong. It just does not work that way. And in 2017, it was way worse. But the biggest savior here was this Ruby gem called Fastlane that actually drove a lot of the UI interactions in some of these stores and allowed you to actually code these interactions. So we actually contributed quite a few changes to this gem. And the main thing we did here is that we took all that like quirky behavior that we had at Strava and all that quirky behavior that each app store had, and we hid them behind abstractions. So we had an alpha abstraction, a beta abstraction, and a production abstraction. And each one of them was just responsible for taking the appropriate binaries, the appropriate release notes, and publishing it to the appropriate audience. Developers didn't have to think about all the specific details and all the specific terminology. It was just called alpha, beta, and production, and it worked for Android and it worked for iOS in exactly the same way. And again, you know, our notifications just became simpler. Before, developers had to like copy paste these release versions over. That stuff was automatically happening now, and the notes were consistent and were never forgotten. So external QA. This is sort of the like hitch in everything, right? Because we still have this manual process where someone has to test the app and give us feedback before we can push to production. So let's just assume for a second that you actually do need manual QA. You actually want your application to go out into the real world. You want someone to use it on a real phone and tell you if it actually works. And for us at Strava, that actually meant someone going out, you know, running on trails with that application and telling us if it worked, right? So how do you incorporate that into your continuous delivery pipeline that's supposed to be entirely automated? I mean, to some extent, it's not entirely possible. But one thing that we had accomplished is our betas were getting out to our testers automatically. The release notes for what to test, those were getting out to them automatically. So the problem was really the feedback, right? We were waiting for feedback from our QA testers. We were waiting for feedback from our QA testers to figure out if our production should go ahead. So we just solved this by saying, relax, just don't worry about it anymore. I'm just kidding. Actually, it wasn't that simple. What we had to do is, again, it was a sort of a cultural shift. And what we realized is that the reason we cared about the feedback is that we wanted to be able to stop the train from going to the station. We wanted to be able to stop the train if a cow got on the tracks. But if there was no cow on the tracks, if there was no car on the tracks, we didn't need to stop the train. So the only thing the train conductor had to keep an eye out for was if there was an actual big issue, right? If they had to slow down the train and maybe get a fix on the train before it got to the station, they didn't have to wait for that feedback to figure out if they should actually go to production in the first place. So this is all we did, really. We just shifted that cultural expectation and gave the train conductor the capacity to stop a train. But if they didn't actually hit that stop button, the train would just kind of keep going automatically. There's one more piece of the process. It's called cherry picking. So because we have two branches, right? We have the feature branch, we have the train branch that's going to production, and we have a master branch where everyone is continually developing. If we find a bug in our beta, we need to make a fix on that branch. But after that fix is on that branch, we also have to get that same fix back on the master branch. Otherwise, the next train is going to have that same bug, which actually happened quite a few times because developers just forget to do that part of the process. So we built a bot that sends you an interactive Slack message and says, hey, we noticed you made a change to the train branch. Do you want me to try to get this change onto master for you? And if you said yes, Butler would collect all the SHAs that you had in your pull request. It would cherry pick them onto master. It would run all the tests, and then it would merge that to master if everything was a success and say, hey, congratulations, you no longer need to do anything. If there actually was an issue, let's say there was a rebase conflict or test didn't pass, you would get a GitHub issue assigned to you that would tell you what SHAs you needed to take care of so that the work was tracked and could be closed out when it was actually complete. This might seem like overkill, but we actually were making about 20 commits to the train branch every single release. So this actually saved us a lot of time and actually improved the stability of our QA builds and our production builds. So the last thing I'll say is, or maybe one of the last things I'll say, I think that the education component of this was something we kind of overlooked or took for granted at the beginning. Because this process lasted for a while and we were able to communicate with developers multiple times throughout it, we really made a robust process because we were able to change just a single thing at once, get feedback on it, build troubleshooting guides, and make sure everyone was on board before moving on to the next piece. Even with everything being completely automated, things will still go wrong. So have your developers having confidence that they will get the correct information at the correct time, and they will have a troubleshooting guide to fix problems when automation does go wrong is extremely important to making automated continuous delivery a success. So we sent out a survey at the very end of this, and we realized that we were now, after having done all this automation, spending only about 2 to 3 hours a week managing our release process instead of the 20 we were having before. Woo! So we decided it was actually worth trying to cut that down to about a week, right? Even if we'd spent like 6 hours, it would still be less than we'd started out with, and we'd be releasing twice as often. It turned out that it didn't actually increase the time very much. Computers scale very well. The process scaled very well. There are minor technical changes that we had to make, but everything actually still worked. I think the biggest change in this is again, a culture of one. We had to shift on what I call the dealing with failure scale. So the longer your releases are, the less likely you are to accept failure, right? If there's an issue in your release and the next release is a year out, you need to fix it now. You can't delay that release. You can't wait another year till that release, right? But if there's a failure in your release and the next release is going out tomorrow, you can accept it. You can reject that release. You can not push it out to users. You can make the fix for the next day because there's just so many releases. And this was the biggest shift, was getting people used to just letting things go and skipping releases or like pulling features out of releases so that releases could go forward. The other thing is that we started realizing there's a larger dichotomy between, or there's a larger shift, there's a larger difference between your code and your release. So for example, if translations weren't ready in a particular language, we could disable that language and maybe not ship it. We could fall back to the English strings if we thought that was appropriate for that language. We could shut down experimental parts of the application that were impacted and still release the rest of the application. All these things are release tools, right? They allow you to feature switch and adjust your application, but without having to change your code. And the shorter we made our releases, the more we started investing in those kinds of tools so that we could have a lot more flexibility. So I'm happy to report that in 2019, this is still a successful process. We've made over 100 one-week releases, and we are still only spending about 2 to 3 hours a week managing this process. Thank you. If you have any questions, I'm Thomakos. You can find me online, and I work at Strava. Thank you. I'm happy to take questions too. Yeah.
Anyone have any questions? I have a mic. You have questions? Yes.
Thanks for the talk. I'm curious, what was your decision making on building your own CI system?
Oh, that's a good other talk. It kind of evolved in the days when what was available was just not working for us. This was like, we actually built it in the days when Jenkins didn't exist, but Hudson existed. And in the very beginning, it was more of a coordinator for Hudson. And we quickly realized that like maintaining the little pieces that Hudson was doing for us was not worth it. It was actually easier to build those small pieces ourselves. It's actually been advantageous because we were able to customize it in ways that we wouldn't with third-party tools. I would say if you were starting from scratch today, use something that's available on the market. But because we've invested in it and it works and it's stable, it's actually running a lot more of our infrastructure now. Yeah.
You just brought us some old school history. Hudson.
Yep. Hudson used to be.
All right, another question.
Hence the name Butler, right? Hudson Jenkins Butler.
So y'all had a README at the beginning, and that kind of was your follow through, like go through this. But now, do you still have like a wiki or anything for people to understand what the process is? Like, is that still necessary to have the documentation on every step that's going through, as far as the technical aspects?
Yeah, so we don't document exactly what every step is doing, except for in the scripts and the code itself. We kind of have a high level overview of what's happening. And the most important part of that wiki is just the troubleshooting guide, right? Like if you get a thing that says, hey, translations aren't ready, what are your options? What can you do? Who should you contact? That kind of information. Yeah.
Can you dive a little bit deeper into like your feature flags you use? Like how many do you have and what tools you use to manage them?
Yeah, we have a few different kinds of feature flags. We have some that are built directly into the binary itself. And I have no idea the number of those. There's probably a lot of them. Then we also have server-driven feature flags. So we're able to, when an application boots up, and I think throughout its life cycle and different stages, it actually gets feature information for the particular athlete that's using the application and the particular device. And we can shut down parts of the application or enable parts of the application through that. Yeah. That's just an API call to get that information.
Thanks. So question about, you mentioned that when you have the release branch cut, you typically see around 20 commits for that. And kind of a two-part for that, I'm just kind of curious where those are coming from. Like, are those from QA, bug fixes for issues found in QA? And does there need to be, or have you ever tried to like lessen that number? Make in some effort, make those release branches cleaner to start with.
Yeah. As we've shortened things, they have gotten much cleaner. So at the beginning, it was a mix of bugs, right? And bug fixes. Those are sort of inevitable. They're going to happen either way. They're just smaller now because if there's a large bug, we're just more likely to skip a release. The other thing was that, as we were doing A/B testing, when we had that 2-week release cycle, if you missed the cut by 2 days, you were very likely to try to get your fix right into the beta branch and get that out. So a lot of the commits were people just trying to get things into the release, right? We were rejecting the failure case there a lot more. So yes, that has gone down now, but I think having that cherry picking bot is still really successful because it makes sure that we don't make any mistakes with it, especially with the bug fixes. Yeah.
So you mentioned that there's 25 engineers. How do you guys manage the conflicts between like PRs and architecture, vision, and all that? Because in my current company, there's a lot of engineers and there's a lot of conflicts, and I don't know how to fix it. And it's impossible to merge anything just because there's so many damn conflicts.
Yeah, so I can't speak specifically to the mobile repositories. I don't think we have a lot of conflicts, and I'm not sure exactly why that is. I suspect that there aren't a lot of people working on the same files at the same time or the same code.
Someone won't let you interpersonal conflicts.
Oh, hire nice people. I'm not sure.
Everyone thinks that they're right, but they're not.
Yeah, I think so. It's maybe a little bit outside the scope of this talk, but I think that might be a time for you to assess like your code review standards and think more about optimizing them so that people are merging sooner and less and focus more on like serious blockers that might break the application or harm the business rather than like nits on a particular way to do things. Yeah. That's what I might try first in that case. Yeah.
Oh, 2 more questions.
So I was wondering if you could talk a bit more about the process of validating a build from beta to production. Like you said that you want developers to assume everything's fine and that the train's going to leave the station as long as there's no alert informing them otherwise. But does that mean you have like monitoring that ships as part of your code to make sure there's like a certain success rate with that code that is going out into the wild?
Yeah, so, and that's gotten more sophisticated over time as well, but we kind of have a dashboard that pulls in a lot of different sources, from QA reports to like metrics, that, like the number of crashes that are happening in a particular beta, and they're targeted for a particular release as well. So you can check like what your error rate is and then kind of build alerts off of that as well. There's still the manual process of like, someone has to look at what QA testers are writing and say, and make a determination about how critical a particular piece of feedback is. But otherwise, a lot of it is automated or like available in graphs now. Yeah.
Just wanted to understand, at what point did QAs engage in the process? Was it on a daily basis? Was it towards the end?
Yeah, at the beginning, we did kind of like multiple QA cycles because we had a lot of changes in a release. I think we have primarily one QA cycle now, and it happens like over the weekend between a release. And so we kind of build the beta, we get as many translations in as we can, we send that out to QA testers, and they get to test it throughout the weekend, and we get all the feedback back by about Monday. Yeah.
More questions. Wow.
You mentioned the process of having your alpha testers be people who are internal employees, or like, I guess, your own power users. That seems like one of the pieces that might not have scaled. Is that something that did scale now in 2019? Do you still have your internal alpha users, the same people who are getting the first builds of everything?
Yeah, so it's available to more than just developers now, because we can push it automatically. So we have like auto update for a lot of employees, and they're getting a build directly off of master continually as well. Yeah. And it's scaled. One weird note about that is, it used to be the case that on iOS, like, or the particular channel we were using with iOS it was really difficult to get more testers. The rules around that have relaxed a lot more now, so we're able to like distribute to hundreds or thousands of testers or alpha people now. Yeah.
Are you using TestFlight?
I think we were using TestFlight and are not anymore, but don't quote me on that. I've heard TestFlight before. We used to use it, but I'm not sure if we're still doing that. Yeah.
All right. Well, once again, let's thank Pan.
Thank you.
Thank you.